and welcome to our webinar on spring energizers. I am your host, Victoria Gamrod, Marketing Manager for MW Components. For anyone who's not familiar, MW Components owns several companies which manufacture stock and custom parts for many industries. I am joined today by Larry Douglas and Paul Ciolli from Maudlin, a premier manufacturer specializing in high-performance, precision-engineered metal components. Larry is a product manager with over 25 years of experience in spring energizers and spring energizer seals. Paul is a product manager with over 15 years with expertise in spring energizers. Larry and Paul will be leading today's webinar, which is expected to last 45 minutes. First, we will review the presentation, leaving time at the end for a Q&A. If you think of questions during the presentation, feel free to submit them in the Q&A section at any time. You'll have access to this by clicking on the Q&A icon at the bottom of the screen. We will address all questions at the end. I will now pass it over to Paul to start the presentation.
Hello, everyone. Our objective today is to explore spring energizer types, uses, and key performance factors. Throughout the presentation, we will have an overview of MW components and Maudlin products, a summary of our product offerings, and we will discuss the types of metallic spring energizers, their applications, load versus deflection performance, and key features and benefits. We will cover material options and availability, as well as spring welding capabilities and our engineering services. Maudlin has quoted or sold to 100 plus companies in 25 different countries outside of the United States. MW Components has 25 plus sites around the United States. Maudlin Products was acquired by MW Components on January 1st of 2015. The benefit to our customers is we now have the capabilities of many other skilled spring manufacturing facilities and a broader spring product offering. In addition to the spring energizers that Maudlin can manufacture, we can now offer Belleville washers, disc springs, fasteners, compression and extension springs, and wire forms. At Maudlin, we manufacture cantilevered V-spring, U-spring, helical spring, full contact or Rayco style spring, etched and formed spring bands or spring rosettes, cavity tools for each style of spring, and canted coil spring. At this point, I will turn it over to my colleague Larry to discuss application considerations for the energizers.
Thanks, Paul, and good afternoon, everyone. Thank you for being here. My name is Larry Douglas. I'm a product manager and application specialist with Maudlin. I've been in the industry for about 25 years. For today's discussion, we're going to talk about the four most common types of spring energizers, which are cantilever spring, which is U and V spring, canted coil spring, helical spring, and full contact or Rayco type springs. And for the context of today's conversation, it will be based on how these springs are used within spring energized seals. We understand that there are other uses, centering elements within concentric cylinders, connectors for electrical and mechanical components, things like that. But today's focus will be primarily spring energized seals. So I'd like to start off by saying that the spring is the skeleton of the seal. If you start with the right spring, you can get a long way down the road to a good solution. And that's what we want to discuss today, is which spring to start with to get you headed in the right direction. So our cantilever springs are a good starting point for a lot of different applications. They kind of cover a wide band of opportunities for sealing, whether it's high temperature or compatibility or load. It's a pretty good starting point. The other springs are a little bit more specialized, and I don't want to say that they're only used for specialty applications. More so, they're used when you have a specific sealing need, like if you have low friction application, or if you have light pressure, or if you have a cryogenic application, you may choose one of the other springs. Each of those is very unique in what it can do, but they can be used in a myriad of different types of applications. So to start with, what is the spring really doing in a spring energized seal? Spring energized seals usually use the U-cup style seal jacket. Now, U-cups have been around for a long time. You look at Parker poly packs and things like this are largely elastomeric type seals in that same type shape. The reason we need a spring energizer is because the materials used for spring energized seals are polymer materials, generally derivatives of PTFE. And PTFE does not have a memory. That is to say, it will cold flow and take the shape of whatever bounds it. So the spring is there to make sure that the lips of the seal stay in place in the absence of pressure. So creating a positive seal requires two things: the system pressure and a spring energizer when you're talking about PTFE spring energized seals. Below 100 psi, now again, that's 100 psi is kind of a rule of thumb. It's not a hard number, but if you're at low pressure, the spring is really creating the sealing force. When you have a startup condition, if you have a light gas, low pressure situation where you don't have system pressure to actuate the U-cup, you need the spring there to keep things in place. Above 100 psi, that U-cup profile takes over, and the pressure is doing the sealing, where the spring at that point is more or less along for the ride. I get asked the question, well, I've got a 5,000 psi valve, the thing's always at high pressure. Do I need a spring? The answer there is yes. If this thing is sitting in a warehouse on a shelf for a year and you go to start it up, if there's not a spring in there, that seal will have collapsed and you'll have a leak right off the bat. So the spring is crucial for startup conditions, low pressure conditions, anything like that, to make sure that your initial seal is a positive one. Spring energizers and connectors. I do have one slide here just to touch on that to show the relative motion of the spring itself. Here we have a canted coil type spring. You see the profile here. When it's first installed, it's in what we call the free height. When it is compressed, you can see that it's squeezed radially in this case, both from top and bottom, and the spring is providing force outward and inward simultaneously to make that contact. It's different than a garter spring that just maybe pulls towards the ID. A canted coil spring pushes out in two directions to make sure the spring stays in contact. So talking about the load versus deflection, these curves, this chart is general. It's not for any specific spring, but we just want to show the shapes of the curves and how the springs differ from one to another. If we look at the three linear springs, you have your full contact, your helical, and your cantilever. I say linear, I'm talking about the curve, in that the more deflection, as deflection rises, force rises, and the cantilever kind of shows that the best. So as we go up in deflection from free height, our force number increases until we get to a yield point. See a yield point, yield point, yield point. You don't want to exceed that yield point. The spring will collapse, will no longer offer force in any direction if we exceed that yield point. And these charts can all be found on our website for the individual springs and their specific load versus deflection curves. The interesting one here is that canted coil. You'll see that it has a nice flat section here where the load doesn't change with the deflection. That's pretty unique in that you can load this thing anywhere along this section and have the same force. So if you have a very friction sensitive application, or you have an application for long life in your sealing, high-speed rotary applications quite a bit use canted coil for that reason, that you have just a nice flat curve and a constant force over the usable life of the seal. So as the seal jacket wears, your force stays the same. Whereas if you look at a helical spring, as that seal jacket wears, your force falls off very, very quickly, which is why we would not recommend helical for any kind of dynamic service. The other interesting thing about the canted coil spring, you'll see from this chart, is the other springs reach a yield point Whereas on the canted coil, the coils butt together. So instead of the spring yielding, you'll go metal to metal, your force will shoot up, and really that coil's butt happens around here somewhere. But that force will shoot up significantly. But if you take that compression away, the coils can open back up, and the spring may not, or the spring may not have yielded at that point, and the seal can still be salvaged. Whereas these other ones, once you reach that yield point, the seal is done. The spring is damaged beyond usability. We'll talk a little bit more about these characteristics a little bit later. So getting into the features and benefits, cantilever spring, like I said, it's good all-purpose spring. These are commonly referred to as your U or your V springs. And we carry both at Maudlin. We manufacture both, I should say. Very good for reciprocating slow rotary applications. We use V spring in, say, quarter turn ball valve applications all the time. Very good application for V springs. High pressure, high temperature, very good for that. The V shape gives a nice point contact on the ID and the OD as it pushes outward from the center of the seal to create that positive seal in that low pressure condition. So very good, just common spring for many applications. Getting into a little bit more specialized is the canted coil. We like this spring, very good for rotary applications, a lot of high speed applications. We specify a canted coil spring. You get that consistent spring load. If you remember, that load curve had that flat section on it. So from basically the initial installation point through maximum deflection, your force doesn't change much. So this is a big advantage when you have friction sensitive or high speed applications. A couple of other benefits of that spring is we talk about run out eccentricity or misalignment. Now, no spring energized seal is good under those conditions, not because the spring can't react, but because the jacket materials that are used are very slow to react. An elastomer springs back very quickly, so you can handle some of these run out conditions. Spring energized seal made of PTFE reacts very slowly. So if there is a spring that's better in a run out condition, it would be the canted coil, although I would not say that if you have a known run out condition that a canted coil spring energized seal is going to solve that. There may be some other things that need to be done. It also is good for installation. So installing these seals into solid glands can sometimes be difficult. You can do it, especially if the seals are a little bit larger. When you get to smaller seals, you can damage the springs installing them into solid glands. Since the coil's butt and the spring doesn't yield when it's over compressed, you can sometimes get away with installing these a little bit better into solid glands than you could with V spring or helical spring. So talking about the helical springs, I love this spring. I mean, it just works. It just really works. The applications that require tight sealing, especially when you don't have a lot of system pressure, the spring is fantastic. It really just seals up tight. The profiles do a good job. Now it's high load, low deflection, so you have to be careful when installing and controlling the dimensions and tolerances of your hardware, because a lower amount of deflection can yield that spring. But as long as you stay within the parameters of our load versus deflection curves, this is a very, very reliable spring. For really high load, we can even double wrap it, where we would take the standard spring and then wrap another coil internally to significantly increase that load. That comes into play for light gases, cryogenics, things like that, where you don't have a lot of pressure, but you need a tight seal. This is a great seal, or spring. We don't recommend it for dynamic applications. The high force, as a result, causes the seal jackets to wear very, very quickly in dynamic service. Now, we have used them. We've used them with materials like UHMW, and in a dynamic application, that's a very, very good wear material. So we have used this spring for tight sealing, low pressure in dynamic, but in general, we would say it's reserved for very slow dynamic or static applications. And yeah, the spring load significantly reduces as that seal jacket wears as a result. Finally, we'll talk about full contact. You may know this spring has Rayco type spring in the industry, but we call it our full contact spring. Extremely high unit load. This one has a very unique feature compared to the others. If you look at this rib here, and it's the same on the other side, this model kind of shows that rib, runs the entire length. There are no breaks in it. If we look back at the helical spring, you can see it has breaks in it. So it does not have structure to it the way this does. The advantage then of the full contact spring is that it's a mechanical support as well as a spring energizer. When we get into extreme cryogenic applications, minus 300 degrees F and lower, the Teflon jacket has a coefficient of thermal expansion 10 times that of the metal that surrounds it. So that seal wants to pull away from the hardware. The advantage of this spring, it has that mechanical support in that it'll keep the seal in place in those extreme cryogenic environments. Fantastic for that. The downside of this spring, unfortunately, is it can only be used for face seal applications, internal or external face seals. And the reason for that is you can't stretch or compress the continuous rib if it's configured radially. It would have to either stretch, tear, or it would ripple and bind up if you tried to use this spring in a radial application. So face seal only. The other downside to this spring is that as good as it is, once it's installed in the seal and in the application, it's very difficult to get it into that position. Maudlin manufactures this spring in straight lengths. The spring then has to be rolled to the basic diameter of the seal that it's going to go into. It is then installed in the seal, and in most cases has to be welded well inside the seal jacket. There are exceptions to that in very, very large seals where you might be able to stretch the jacket over the spring once it's welded. But I would say 10 to 12 inches and under, generally speaking, you have to cut and weld the spring, or cut the spring, roll it, install it into seal jacket, and then weld it in place. And Maudlin can provide the weld tabs and give you some recommendations on process to do that, but we don't roll or weld those springs in-house. Again, we wouldn't use this spring in dynamic applications. Sometimes we have big rotary tables and things that it's used in, but high load, it's going to have accelerated jacket wear again, similar to the helical spring. So the materials that we offer. Now these, we list here kind of our standard material for each spring. Cantilever is going to be a 301, canocoil 302, helical is a 17.7 pH for its better mechanical properties. Then the full contact spring again is going to be 301 stainless. We also offer options, and these options are things that we have produced. They're not the only things that we can do. We can do Inconel, both 718 and X750. We can do other materials upon request. Sometimes there are minimums, sometimes there are long lead times. But these are the materials that we do most commonly, our standards that we generally will have on the shelf. And then, 316 Hastelloy Elgiloy and a cantilever. We've been doing a lot with beryllium copper lately with the canocoils. Helical, Elgiloy is big for helical for its NACE compliance and its good mechanical properties. And then full contact we do, and those come up in a lot of just 300 series stainless steels. But we have these options and then others upon request, if need be. Spring welding, this is a critical component, and Maudlin has found a very unique way, and we think the best way to do the welding. We've gotten a lot of feedback on seal failures from our customers that bought spring, and either they welded it themselves or they didn't weld it at all, and they were having seal failures occur. A couple things can happen. If you overlap the springs, you get a high point, that's going to cause the seal to wear prematurely at that high point. So if the spring overlap is causing a lump in the seal jacket, we've seen that quite a bit. In terms of failure mode, we've also seen where the spring is cut too short by the customer and there's a gap, and that gap allows for the seal to be unsupported in that area, and you'll get a leak past that point. So Maudlin recommends welding every spring, and we offer a laser welded um, technology for doing that, and it differs from the spot welding that is probably more common in the industry. And that laser welding, you can see here, this is just a cantilever spring. Um, we weld down the tab, so we cut that tab and weld down it, and the idea is to produce a continuous spring profile, as if the spring were one piece, as opposed to being a length that's rolled and welded, as if it was one continuous circular piece. And this laser welding is the way that we've come up to do that. And we pull test this. The base material usually stretches and yields before the weld breaks, so the welds are very, very strong. That sometimes comes up as a concern, but that weld is stronger than the base material in most cases. Um, for critical applications, there's no other way to do it. Now, Paul mentioned the rosettes and um, the smaller type springs. Those do not have a weld, but they're pretty specific. We can't make those to any diameter. Those have to be basically a standard dash number size, usually a 0 series or a 100 series for a rosette. But that's something that if you have questions on that, we can talk about that offline. Welding the other types of springs for helical, we do have a little bit of overlap, but that overlap can be placed either at the heel or at the opening of the groove, so it doesn't affect the seal jacket. And then we would weld across this seam here, whereas the spot weld may be on top. And then for canted coil, we'll butt the coils together over, a certain amount of length, and then just weld down that seam as well to give a continuous spring. And for radial versus axial configurations, there's slightly different types of positioning of those coils to get the best weld, but that's the general way these are welded. We also offer engineering services. Now, we don't just want to supply a part, we want to help be a part of the solution that you're trying to create. So the engineering services, obviously spring type selection. We talked about the spring being the skeleton of the seal. Let's get the spring right first in the application and then go from there, and that'll get us a long way down the road. We also offer material selection guidance. So NACE compliance, FDA, cryogenics, whatever it may be, we can help get that right material, and we offer myriad materials for all the various applications. We can do some failure analysis. Like I said, if we look at a seal or a spring failure, we can try to pinpoint that root cause and help put together corrective actions so that we don't repeat that same thing. Hardware design and support, that's an important one, and that kind of factors into failure analysis as well. A lot of times when we see a seal failure, we'll see an extrusion of the seal jacket due to an overpressure, or we'll see the high points that we talked about for premature wear, the wrong spring being used in a dynamic application. But a lot of times the hardware is the culprit. So we talk about surface finish, we talk about dimensions and tolerances on the hardware, and we talk about, probably most importantly for spring energized seals, is surface finish. O-rings can live in an environment of 32 RA type finishes, 16 maybe, whereas spring energized seals, 8 to 16 is common on a dynamic surface, sometimes better if you're doing vacuums or light gases. Um, uh, those types of things really factor into the hardware design and support, and we can help with recommendations there. We can do some finite element analysis. We don't do complex assemblies for computational fluid dynamics and heat transfer. That's not the that's not the kind of finite element analysis that we're talking about. But we can take singular parts. You have a V spring, you want to change the base material thickness or the material itself and see the effect of what that might mean for that spring. Those are the kinds of things we can do. Single piece parts. We've done centrifugal analysis to see if the spring has enough force to keep the lip in contact at certain RPM of a given application. So things like that we can do, but they're large assembly FEAs. That's not what we mean when we say FEA. It's more for developing new product and looking at what that might look like for the application. Spring grooves and tools, we do those. We have a set of custom tools all of our um, for all of our springs, and we have those on the shelf and available. We can also help design custom tools if we're doing custom springs, and the goal is to provide the tool to cut the groove to work with the spring all seamlessly when you're doing your seal design, and we can help with that as well. Force versus deflection analysis, we have all the curves on our website, but if we do a custom spring, we test all of that in-house. And we can usually do new curves pretty quickly. Application consulting, so that kind of encompasses everything. We don't require you to give us all your application details like some companies do, but if you want us to help look at the application and get going in the right direction, we're happy to do that. You can share as much or as little information as you want, but we can take a look at that and say, hey, this looks like maybe it's a better fit for a canted coil than it would be for a helical, those kinds of things to help get you going in the right direction. And finally, we do these technical presentations and training seminars. We can do them one-on-one at your place of business. We can bring people in and do it at ours. If you want to get a shop tour, which I highly recommend, the shop is fantastic and very well run. So if there are specific application needs that you have and you would want somebody from Maudlin to come in and do a technical presentation, that can be set up as well. Okay, I'm going to kick it back over to Victoria now. Thank you very much.
Thank you, Larry and Paul. We do have a few questions from the audience. If you haven't sent in your question yet, please enter that in the Q&A section. If you have a question you'd prefer to ask privately, feel free to email any of our presenters. They'll be happy to respond directly. Contact information is shown on the slide on your screen now. All right, let's get into the questions. Our first question is, what is the best spring for vacuum applications?
I'll take that one. For vacuum, we generally go with a helical spring because of its versatility and availability. It's versatile in that it can be used in both radial and face seals. It gives a very, very high unit load. Vacuum applications often we see where you have a forward pressure, but then during a shutdown or a system upset, you might have a siphoning effect where you'll have to keep that seal in place while the vacuum's pulling the seal from the front side. And that helical spring will make sure that you still have the seal even when you have that vacuum condition. Very, very high unit load. It's also available in several materials, and we have that double wrap option as well. So for vacuum, I would recommend the helical spring.
Great, thank you, Larry. Next question is, how is proper spring deflection determined?
Oh, again, we recommend on our load versus deflection curves, we have a recommended installation point shown and then a yield point, or where the coil's butt in the case of the canted coil spring. So we will give you that information on the website on the curve. If it's a curve that doesn't exist, we can help determine that, but we generally try to go somewhere between 75 to 85% of yield, depending on the cross section and so forth, to get to that installation point. We also have some test data and feedback from customers that have helped us determine that ideal load point at installation.
Awesome. Next question is, can I buy a spring groove tools from Maudlin?
Yes, absolutely. So for most of our standards, if not all of them, we have them off the shelf, and we do have the custom option as well, where we can help if it's for a custom spring.
All right, and our last question for now, if anyone does have any other questions, feel free to enter those in the Q&A. But last question we have for now is, does Maudlin manufacture seals to go with the springs?
Yeah, so we get that question a lot, actually. We are not a seal manufacturer. If it's not metal, Maudlin doesn't want to do it. So, that's why we offer the engineering services. We can definitely help design a seal that will work seamlessly with the tools and grooves and whichever spring is determined to be the one for the application. But beyond that, no, we do not manufacture seals.
Great, thank you, Larry. We did get one more in. It says, please touch on when you would choose to heat treat the spring material, for example, alloy, and how it affects the spring force.
Sure, that's a good question. Well, we heat treat when we need to increase that spring force, as you mentioned, and depending on the cross section, we generally see with the heat treat 10 to 20% increase in load capability. And for light gases, that can be very, very important, especially when you're static environment. You can increase that load by, call it 15% to be safe by heat treating a helical spring.
Great, thank you, Larry. Those are all the questions that we have gotten today. If you do think of additional questions, please feel free to reach out to our presenters. They'll be happy to assist you further. Their contact information is on the screen right now. Thank you all for joining us. We will be following up with a link to the webinar, so if you can share it with your peers or use it for reference later. As a reminder, MW Components manufactures stock and custom parts, including springs and disc springs, fasteners, and metal bellows, couplings, and other precision metal components. For more information on MW Components, products, services, and available resources, including white papers, case studies, and webinars, visit mwcomponents.com/resources. This now concludes our webinar. Thank you for listening and have a great day.